Hey there folks, Dr. Saul, the solving surgeon, back talking to you about solving equations for a specific variable. Now here's a question. What did the doctor say to the patient who complained about feeling invisible? I can't see you now.
First vocabulary term is a formula. That's an equation that states a relationship among quantities. So down here you can see a bunch of the formulas that we use a lot in both algebra and geometry. You don't necessarily need to memorize these right now, but in the future you will have to have most of these memorized. A factor is a number or algebraic expression by which another is exactly divisible. So here you can see our number 2 has factors 1 and 2 because both of those numbers can divide into 2. 6 has factors 1, 2, 3, and 6 because each of these numbers can divide into 6. 12 has factors 1, 2, 3, 4, 6, and 12 because each of these numbers separately can divide into 12. What about 3x? Well, we know 1 can divide into 3x, 3 can divide into 3x, and x can actually divide into 3x as well. 2x plus ax. This one is tough because you have two separate terms. So what you have to do in order to figure out your factors is something called factoring. So is there a greatest common factor that goes into both of these? Yes, x divides into both of these terms. So what we can do is actually something like reverse distributing. Because each of these has an x, I can actually take an x out and I put it on the outside of the parentheses. So it would be x parentheses 2 plus a. So if I do that, you can see your two separate factors, x and the quantity 2 plus a. That's why those are your two factors. Just like down here, since these are both multiplied together, those would each be your factors. And it makes sense, right? Because if I divide this by x minus 2, the x minus 2's cancel out. It's divisible by x minus 2. It's also divisible by x plus 5. Let's review real quick order of operations in case you forgot. PEMDAS, P stands for parentheses or brackets. You got to do whatever is inside those first, followed by exponents, then your multiplication or division, addition or subtraction at the end. Now again, it's multiplication or division from left to right, addition or subtraction from left to right. This is what we use to simplify expressions. Solving equations for a specific variable this time. Says when solving equations for a specific variable, our goals are to simplify, move, then solve. So we're going to simplify each side if possible. Then we're going to move the variables you're solving for to the left side of the equation and move the constants and all other variables to the right side. Then you can solve for your specified variable.
What do you call a vet who only helps canines? A dogter. It's a good time.
Now example 1 says solve the given equation for y, then complete the table provided. So here we have our equation right here. We're going to solve it for y. So again, simplify, move, solve. First, can we simplify this side? No, this has an x, this has a y, so that can't be simplified. And this side is 20, already simplified. Cool. Step 2, move the variable you want to the left. So we are solving for y, so y is already on the left side of the equation. Sweet. Step 3, move the constants and all other variables to the right. So this negative 8x has to go over here. How do I do that? Well, I need to do the opposite. Since it's negative 8x, I'm going to add 8x to both sides of the equation. Now these over here are going to cancel each other out. These I cannot add together because this is 20 and this is 8x. This has an x, this does not. So I'm just going to write it out, 8x plus 20. You could also put 20 plus 8x. That would mean the same thing by the commutative property. Now again, we're solving for y. So we need to get all the constants and other variables to the right side. So we got the variable over here. Now we got to move this constant, negative 4, to this side. How do we do that? Well, it's negative 4 times y, so I do the opposite. The inverse, I divide both sides by negative 4. These are going to cancel out, and what happens over here is now I have y is equal to 8x plus 20 over negative 4. Now, I don't want to leave it like this. So what I can do, because this is all one fraction, I can take negative 4 in my denominator and put it under each term in my numerator. Now I can simplify it a little further. I have y is equal to, what's 8 divided by negative 4? That's negative 2. So it's going to be negative 2x, and then over here, 20 divided by negative 4 is going to be negative 5. And I'm done. Now I have to complete the table provided. So I have y equals negative 2x minus 5. I want to figure out what y equals when x is equal to negative 1. So I'm going to take negative 1 and plug it in my equation that I just solved for x. And when I do that, now I use PEMDAS, order of operations. There's nothing I can do inside parentheses. There's no exponents. Multiply and divide from left to right. Yes, I can multiply the negative 2 and the negative 1 and get positive 2. And then adding or subtracting, I can subtract 2 and 5 and I get negative 3. That goes in the table next to negative 1. What about when x is equal to 0? I take my equation that I just found. I plug in 0 for x, and now I solve for y. So what is negative 2 times 0? That's going to be 0. 0 minus 5 is negative 5. Lastly, I am plugging in 3 for x in the equation that I just found and finding the y value that goes with that. So when I do, I get negative 2 times 3, which is negative 6, minus 5 is the same thing as adding the opposite, so plus negative 5, so that'd be negative 11. Cool, done.
What's the name of the weirdest physician? That's going to be Dr. Strange. You try.
Okay, so again, simplify, move, solve. Can I simplify this side? No, this has an x, this has a y, and this is already simplified. Cool. Step 2, variable that I want on the left. Y is what I'm solving for, so it's already on the left side of the equation. Done. Step 3, all the constants and other variables need to go to the right. So this 6 has to go over here and this x. We start with anything added or subtracted to our variable that we want, so that would be this x. To move that over here, since it's positive x, I do the opposite. I subtract x from both sides. These cancel each other out, and then over here, 36 minus x, this has an x, this does not. So don't try to subtract these. It's just going to be negative x plus 36 or 36 minus x, either way. Now again, y has to be by itself, so I got to move this 6. Since it's 6 times y, I got to do the inverse. I divide both sides by 6. Now these 6's cancel out, and I get y is equal to negative x plus 36 over 6. Now this can be simplified, right? We said anytime you have one thing in the denominator and multiple terms in our numerator, we can divide each term in the numerator by the denominator and create separate fractions. Now I get y is equal to negative 1/6 times x plus, what's 36 divided by 6? That would be 6. Cool. Now what I need to do is fill out this table, so I'm going to take the equation that I just found, and I'm going to plug in negative 3 for x, and get the y value that goes with that. So how do I multiply these together? Well, negative 3 is the same thing as negative 3 over 1, so you're just multiplying fractions together. You multiply the numerators together, multiply the denominators. So what is negative 1 times negative 3? That's positive 3. What's 6 times the 1 in the denominator right here? That'd be 6. So we get 3 over 6, which is 1/2. Now I can simplify this. If you wanted to, you can create an improper fraction, but you don't have to. 1/2 plus 6 is just 6.5. Cool, done. Next, when x equals 0, what does y equal? Well, we take our equation that we just found, we plug in 0 for x, and now we use the order of operations to solve, so there's nothing to do inside parentheses, no exponents, but we can multiply these two together. 0 times negative 1/6 is just 0, plus 6 is 6. Cool, that goes in there. And then lastly, we're going to plug in 12 for x. What is negative 1/6 times 12? Well, remember, 12 is the same thing as 12 over 1. So I just multiply the numerators together and denominators. So it's negative 1 times 12, that's negative 12. What's 6 times 1? That's 6. So we get negative 12 over 6, which is equal to negative 2. Now, negative 2 plus 6 is going to be 4. So that is the y value that goes with 12 for this particular equation. Example 2 says solve each equation for the specified variable. So here we are solving for y, just like we were doing. And remember, when we are solving, it's simplify, move, solve. This time it's for a specific variable. So step 1, can we simplify anything? No, this has an x, this has a y, cannot combine these two. And this is 12, so we're done. Step 2, we need to keep our variable that we want on the left. Done. Step 3, we need to move constants and all other variables to the right. So we start with anything added or subtracted to our variable. So that would be this negative 2x. Since it's negative 2x, we're going to add 2x to both sides to cancel these out. And over here, 12 plus 2x, we cannot combine these because this has x and this does not. So we just write it out as 2x plus 12 or 12 plus 2x, however you want to write it. Next, we need to move this constant to the other side. So remember, since it's 5 times y, I got to do the opposite, the inverse. I divide both sides by 5 and these cancel each other out. And I'm left with y is equal to 2x plus 12 over 5. Now again, I don't want to leave it like this. I'm going to take each term in the numerator and divide it by my denominator, create two separate fractions to make it look something like this. Usually they will simplify, but here it does not, and that's okay. You can leave your answer like this. Part B, we're going to solve for m this time. So here, simplify, move, solve. Can we simplify this side? No, this is mx and this is nx. So those are two separate terms that we cannot combine. They're not like terms. And this is just p, so we're going to leave that. Next, we're going to move the variable that we want to the left. Done. Step 3, constants and other variables need to go to the right. So we start with anything added or subtracted to our given variable. So m is what we want. We're going to start by moving this guy right here. So how do we do that? Well, it's positive 2nx, so we're going to do the opposite. We're going to subtract 2nx from both sides. These cancel each other out, and I'm left with, we can't combine these, so it's going to be p minus 2nx. Now that we have mx on one side, we want just m. So x is another thing we have to move. So it's m times x. So in order to move it, you got to do the opposite, the inverse. We got to divide both sides by x. These cancel out, and you're left with m is equal to p minus 2nx over x. Now again, just like over here, I want you to simplify it a little bit. So what we're going to do is we're going to divide each term in the numerator by x. The reason we do that is because p over x, that's going to stay like this. but over here, this term in the numerator has an x, and this denominator has an x. So what we can do is cancel those out, and we're just left with m is equal to p over x minus 2n.
How does a rabbit greet its physician? They say, "What's up, doc?" It's a Bugs Bunny. You try.
Simplify, move, solve. This time it's for a specific variable. So, step 1, can we simplify this? No. This has A, this has B, so it can't combine. Can we simplify this? No. So we're done. Step 2, variable that we want on the left. Done. Step 3, we need to move constants and all other variables to the right. So, we start with anything added or subtracted to the variable that we want. So we start with A. How do we move that to this side? Well, since it's positive A, we do the opposite, the inverse. We subtract A on both sides. These cancel each other out, and then over here, you can write this two separate ways. You can go -10 minus A, or you can go -A minus 10, either way. Now, what we can do is we can get B all by itself. How do we do that? We got to move this last constant to the right. Since it's -2 times b, I do the opposite, the inverse. I divide both sides by -2. These cancel out, and I'm left with b is equal to -a minus 10 over -2. Now, what we're going to do is we're going to take this denominator and put it under each term in the numerator and create two separate fractions. The reason we do that is because now we can simplify. This right here just becomes 1/2 a, and this right here, since this is minus 10 over -2, that's the same thing as plus -10 over -2. So this just becomes a positive. These are going to cancel each other out. And then 10 over 2 simplifies to 5. And you're done. Here, to solve for x, we are going to first simplify, move, solve. Can we simplify? No. Can we move the variable to the left? It's already there. Perfect. Step 3, we're going to move the constants and all other variables to the right. So, how are we going to do that? Well, first we have to, if we're solving for x, we got to move anything added or subtracted to it. So, we're going to subtract 3pq from both sides. Why? Because this is positive 3pq, and so we have to do the opposite, the inverse. We subtract. That way these cancel out, and we're left with 1/2 x is equal to p minus 3pq. Now what I can do is I can get x by itself by getting rid of this fraction. How do I get rid of this fraction? Usually it's 1/2 times x, so I would divide by 1/2. But dividing by a half, dividing by a fraction, is the same as multiplying by its reciprocal, right? So you could technically multiply both sides by 2, or 2 over 1. You could also remember that when we talked about when we have any fractions in our problem that we want to get rid of, we just multiply by the least common denominator. Here, the only denominator is 2, so we multiply everything by 2. The reason we do that is because the 2 and the 1/2 cancel each other out, because 2 over 1 times 1 over 2 becomes 2 over 2, which is 1. So those cancel each other out, so we get 1x is equal to 2p minus 6p. Okay, example 3 is to solve each formula for the specified variable. So we're going to solve for the base. This is the area of a triangle formula. We have area is equal to 1/2 the base times the height. So we want the base. We need to simplify, move, solve. Step 1, can we simplify? This side is already simplified. This side, these are two separate variables. You can't simplify anything. So step 2, move the variable that we want to the left. We want the b. We want that on the left side. How do we do that? Well, anytime it's in the beginning of the equation and your variable is on the right side, I would flip the equation. Sweet. Now our variable is on the left side of the equation. Step 3, constants and other variables to the right. So the 1/2 and the h got to go over here. How do we do that? We'll start with the 1/2. Remember, anytime there's a fraction in the problem, you're going to multiply both sides by the least common denominator. And anytime there's one fraction, that would be the only denominator here, which is 2. So we're going to multiply everything by 2. The reason we do that is because the 2 and the 1/2 cancel each other out, because 2 over 1 times 1 over 2 becomes 2 over 2, which is 1. So those cancel each other out, and then over here, we just get 2 times a, which is 2a. Now, lastly, to get the base by itself, again, this is b times h, so we need to get this h over here. How do we do that? We just divide both sides by h, because b times h, the opposite, the inverse, would be dividing by h. So these cancel out, and we're left with the base is equal to 2a over h. Next, it's the perimeter formula for a rectangle or a square. So we have perimeter is equal to 2 times the length plus 2 times the width. How do we solve for the width? Simplify, move, solve. Step 1, can we simplify? No, this has L, this has W. Those can't be combined. So step 2, move the variable that we want to the left. Flip your equation. Sweet, now the variable that we want, W, is on the left. Step 3, constants and other variables to the right. So you start with anything added or subtracted to your variable, W, so that would be this 2L is added to it. Since it's positive 2L, to move it to the other side, we do the opposite. We subtract 2L from both sides. Now you could write this as P minus 2L over here, or negative 2L plus P, either way. Again, we want W by itself. Since it's 2 times W, we do the opposite, the inverse. We divide both sides by 2, and we get W is equal to P minus 2L over 2. Now we said, anytime you have something like this, where you have one thing in your denominator, we're going to split it up. So it's two separate fractions. It's going to be P over 2 minus 2L over 2. This can't really be simplified. We can change it to 1/2 P. That's about it. But over here, the 2's actually cancel each other out, and we just get minus L. Example 4 says solve each equation for the specified variable. So here we're going to solve for y. Step 1, we need to simplify. Can we simplify this? Well, this has a y and this has a y, but this also has an x, so we can't combine them. They need to have both of the same variables. So can't be simplified. Step 2, variable that we want on the left. Yes, there's actually 2 of them this time. There's a y here and a y here. Perfect. Step 3, constants and other variables to the right. So these constants, the -5 and the 6, and the x all have to go over here. Here's how you do this. Anytime you have 2 or more terms that have the same variable, what you can do is something called factoring. It's basically reverse distributing. So I'm going to take this y from this term and this y from this term and put it out front of a set of parentheses. I just reverse distributed the y. So now you can see if I were to distribute this y here and here, I would get this up here, but I just took it out. That's called factoring. Now, why did I do that? Because now I have the y right here, and all I have to do to get the y by itself is just divide both sides by -5x plus 6. And now I do this because the -5x plus 6 up here and the -5x plus 6 down here cancel each other out, just leaving me with y. And I'm done. There's no way to break this up into 2 separate terms. We only have 1 term in the numerator, so we just leave it like this. For part B, we're going to do the exact same thing. We're going to simplify, move, then solve. So how do we do this? Well, first, we need to simplify. Can we simplify? Well, this is mx, this is nx. So they are not the same variable, so we cannot simplify. So we move to step 2. Can we move the variables to the left? Yes, we already have the m over here from mx, but we need this m from mp over here as well. So how do we get this to the left side of the equation? Well, since it's positive mp, we do the opposite, the inverse. We subtract mp from both sides. These are going to cancel out, and over here, don't try to combine these. Okay, you're just going to write it out just like you see it. mx minus mp plus 12nx equals 0. Now we have all the variables that we want on the left side. So step 3, all the variables and constants we don't want got to go to the other side. So let's do that. We start with anything added or subtracted. So this 12nx has to go over here. How do we do that? Well, since it's plus 12nx, we do the opposite, the inverse. We subtract 12nx from both sides. We get mx minus mp is equal to negative 12nx. Now I have the variables that I want over here, but they're each multiplied to a different variable. So how do I do this? Well, just like over here, anytime each term has the same variable, what you can do is you can reverse distribute. You can factor. And how do I do that? Well, I just write my m on the outside of the parentheses, and on the inside of the parentheses, I have x minus p. Now, all I have to do to get m by itself and solve this and get all the other variables to the right side is divide both sides by x minus p. Both of the x minus p's here are going to cancel each other out, and I just get m is equal to negative 12nx over x minus p, and you're done.
Out of the 7 dwarfs, which is a physician's favorite? That's gonna be Doc. You try.
Okay, we'll start with this one. Simplify, move, solve. Can we simplify this? No. Can we simplify these? No. So we move to step 2. Variables that we want, gotta go to the left. So I want x on the left. I already have an x over here, so I gotta move this guy right here. Since it's positive x, I do the opposite, the inverse. I subtract x from both sides. Now this has an n, this does not, so don't try to combine these. You're just gonna write it out. 2m minus nx minus x is equal to 4. Now I have all the variables that I want on this side, so I need all the constants and other variables over here. So I start with anything added or subtracted. There's no x's in here, so I'm going to move that over here. Since it's positive 2m, I'm going to subtract 2m from both sides, and those cancel each other out. I'm left with negative nx minus x is equal to negative 2m plus 4. You could also write 4 minus 2m. That's the same thing. Next, I need to get x by itself. Since each of these terms has an x, I can reverse distribute. I can factor. And I'm going to take an x and put it out front of a set of parentheses. And in the parentheses, I'm going to put negative n minus 1. Now you know this right here is the same thing as this because you could distribute. And you see, you would get the exact same thing that you see right here. Now, all I have to do to get all of the other constants and variables to the right side to finish off step 3 would be to divide both sides by negative n minus 1. Now when I do that, these are going to cancel each other out. And I'm left with x is equal to negative 2m plus 4 over negative n minus 1. Now, you could leave your answer like this. I would accept it. But what you can do is you can multiply the numerator and denominator by negative 1. And all that would do is you would distribute the negative 1 in the numerator and the denominator and make it so it's x is equal to 2m minus 4 over n plus 1. Okay, it just looks nicer than this one. Okay, part B, again, simplify, move, solve. Can we simplify this side? Yeah, actually, we have two like terms. We have 2c and this 6c, which we can add together and get 8c. Sweet. Can we simplify these? No, this has a c and this has a c and a d, so no, those can't be simplified. So we move to step 2. Variable that we want on the left. Done. Step 3, constants and other variables got to go to the right. So, how do I do that? Well, these both have a c, so if you recall, if these both have a variable that we want, we do something called reverse distribution or factoring. We're going to factor out a c. So we take the c, put it outside the parentheses, and on the inside of the parentheses is just 8 minus 3d. And again, you could distribute this and get this. That's why they're equivalent. So I take out that c. Now I can just divide both sides by 8 minus 3d. These are going to cancel each other out. I'm left with c is equal to 15 over 8 minus 3d. And you're done. Okay, let's finish off with a word problem. It says a public park is in the shape of a triangle. The side of the park that forms the base of the triangle is 200 yards long, and the area of the park is 7,500 square feet. If the area of the triangle formula is a is equal to 1/2 base times height, what is the length of the side of the park that forms the height of the triangle? So, word problem. Step 1, don't be scared. Step 2, we need to figure out what is it asking us to find. Well, it's asking us what is the length of the side of the park that forms the height. So we're trying to find the height, which means step 3, when we define our variables, we'll start with h is equal to the height of the triangle. Now, we're going to write our equation. We start with, is there any total? Is there anything it's equal to? Yeah, the area is equal to 7,500 square yards. Also, can we just use A as the area of the triangle because we're given a formula? A is the area of the triangle. We're also given the base of the triangle is 200 yards long, so B would be the base of the triangle. If we have this formula now that we're given, there's two things you can do. Two ways you could solve this. One would be to straight away substitute in 7,500 for our area and 200 for our base. Then you can simplify that and solve for h that way. Or, since we're solving for h, we can solve this equation for h and then plug it in. Either way, you'll get the same answer. So what I'm going to do, since we've been doing this today, I'm going to solve for h first. So again, when you're solving a problem, what you need to do first, simplify, move, solve. So let's simplify. Can we simplify this side? No. What about this side? No. Next, move the variable that we want to the left side. So we want the height. How do we get that by itself? On the left side of the equation? Well, let's just start with moving it. How do I move that? You can just flip the equation. Boom, done. Next, we need to get all the constants and other variables to the right. So we start with this 1/2. How do we move that? Again, anytime you have a fraction in your problem and you want to get rid of the fraction, you multiply everything by the least common denominator. Since there's only one denominator, multiply everything by 2. Now these are going to cancel each other out. That's why you did it. And over here you get 2a. Now we have base times height is equal to 2a. How do I get the height by itself? I got to get rid of this b. Since it's b times h, I'm going to do the opposite, the inverse. I divide both sides by b. These cancel out. I'm left with the height is equal to 2a over b. Now I have the height solved for, so I can substitute in the area and the base. What is the base? 200. What's the area? 7,500. Plug those in. Now I can simplify. Remember, when it's a fraction, you simplify the numerator first, then the denominator, then divide. So multiply these two together, and I get 15,000. Divide that by 200, I get 75. Do not write this as your answer. Your answer is going to be the length of the side of the park that forms the height of the triangle is 75 yards long. And you're done.